Hello everyone, this is Ajinkya Bhosle. So I am here going to explain you about the CAD technology. So what do you mean exactly by the CAD? So CAD is nothing but it is the computer aided design or drafting. So in this topic we are going to cover what is engineering drawing, then elements of engineering drawing, types of engineering drawing, orthographic and isometric drawing. So first start with what is engineering drawing. So what is basically engineering drawing? So engineering drawing is nothing but it is the communication between the sender and receiver, or we can say it is the technical drawing which clarifies or it defines and communicate about the design to each other's interested party, or that party may have interest in design collaboration with procurement, purchasing, costing, manufacturing, quality control, marketing, handling, packaging, anything. So it is basically between the communication between the two peoples who is going to design and who is going to produce who. So we can say it is the communication between input and output. Then if you talk about the importance of engineering drawing, so basically engineering drawing it help as a reference to the worker, technician or architect who is going to actual making the component or producing on the anything which on the job. So it helps them to understand what exactly has to communicate between the designer and end user. Second one, if you see this, it is easy to understand since picture is easiest medium than the thousand words, and the technical drawing is much more effective tool for engineering than the written plans. So we can say this engineering drawing it communicates better, okay, as compared to any other media. So that is why engineering drawing is very important. And if you see this engineering drawing is used for all engineering fields including all civil engineering, electrical engineering, mechanical engineering, architecture. So there are various departments in engineering that we are going to communicate by using this engineering drawing. Then if you talk about engineering drawing, so first we have come across the conceptual case. So what is conceptual cases sketch? So it's nothing but when a designer has any idea in his mind, then he has to actually draw it on a simple paper by using pencil and like anything. And it's kind of imaginary what we have in your mind that we have to put up on a paper. So it is nothing but it is the conceptual sketch. So this is kind of example of the any conceptual case. So this is how the design start. It is the first step for the engineering drawing or designing, we can. So what is sketch and what is engineering drawing? What is basic difference between this? So sketch is nothing but it is made without drafting tools, or we can just take a pen and pencil paper and drawing something which is first come into your mind, and it is not accurate, it is just approximate, but the sketch it still look like an object, right? So this is kind of a sketch. And when we want to make this idea in actual way, so if you want to make it in actual way, so there is a concept of engineering drawing. So it is made up with all of the drafting tools, we can say ruler, set square, protractor, compass and all that. With the help of this engineering drawing, or we can say tools, we are going to draw this engineering drawing. So scale should be about the accurate and drawing carefully made. So this is the basic difference between the sketch and engineering drawing though. So we can say sketch is approximate and engineering drawing is with respect to actual scales that we are going to produce an object by using engineering drawing. this, so anything comes to your mind, that is if you see this car, example of this car. So first we are going to produce the sketch with respect to freehand sketch, we can say. Okay, and so with the help of this pencil and paper without any instrument, so this is freehand sketch, we can say that. Drawing, so with the help of instrument, we can say protractor, compass and all that, by using this instrument we are going to draw the lines, circles, curves very concisely and accurately. So thus drawings are usually made to the scale. And if you see this, this is the example of this engineering drawing, how it look like, right? And when we are going to draw this engineering drawing with the help of computer, then we can say it is a CAD, or we can say computer aided design or drafting. And we know that there are a lot many softwares in the market. So AutoCAD is there, SolidWorks is there. Okay, so this drawing is usually made by these are the some commercial softwares. Okay, then next topic is what are the elements of engineering drawing, means which with with which elements will take part in engineering drawing, and how we are going to define these elements in engineering drawing. So engineering drawing are made up of some graphic language and word language. Okay, so when we come across any engineering drawings, there are two types of basic language, that is graphical, and the second one is a word. So what is that? So if you see this, this is the this is the three-dimensional object, and if you want to represent it on a 2D, then look like this. So if you see this, so this is how it is going to look like this. Okay, so this is the 2D two-dimensional view, and if you see this, these are some dimensions given over there of this object. And if you see this, so there are two languages, that is graphic language, which mainly describe the shape, right? So if you see this red mark, so this is nothing but it is the graphical language. So it is not only that we are going to use this graphical language, so there is one another thing that it is very important in engineering drawing, that is word language. So what is word language? It describes your locations, some dimension part, some specification, describing size, all this comes into this word language. So if you can see this, this is the graphical language it has. If you see this red color, and second one is word language, so you can see this orange color. So by using this graphical language and word language, we are completely see this is the engineering drawing. So this is the basic elements of engineering drawing. So basic knowledge of for the drafting, so we will see what all includes in graphical language, and what all includes in a word language. So if you see this graphical language, which includes line types, there are various types of lines are there. Then we have projection methods, then we have some geometrical constructions. So these lines, projection methods, some geometrical constructions, which forms a graphical language. And what it forms in word language, it's totally about the lettering, or we can say whatever the numbers are there, which shows the dimension or a size of that object. So lettering is included in a word language. So this is the basic drafting knowledge that requires the graphical language and word language. So what are the types of drawing? So if you see this, there are a lot many types of the drawings we have, but how we can technically differentiate all these drawing. So basically all the drawings are actually divided into two branches, that is artistic drawing and second one is a technical drawing. So this artistic drawing is another branch, or we can say whatever the artist they are doing some paintings and all that. So this actually includes, so if we talk about some fashion industries and some another industries we can talk about, so these artistic drawings are used. So this is not our concern for this topic, so we are restricted to here this artistic drawing. We are actually deals with this technical drawing. So if you see this is the technical drawing we are going to see this. So what are technical drawings includes? So technical drawing includes some sketches, then some diagrams, then drawing techniques. Okay, so these cases is nothing but these are the conceptual sketches we have. Then this diagram is nothing but some design and technical things that we have to keep it on a paper, and that they include some design plans, some technical diagrams. Okay, so this includes in the diagrams. So what is drawing? So technical drawings are engineering drawings which again divided into this simulated perspective and this multi view orthography. So simulative perspective, it again includes the oblique projection and isometric projection. So if you see this moreover, so we have to concentrate on this part. Okay, so this part, that means this is isometric projection and multi-view orthographic projection. So we are going to concentrate basically on these two types of drawing. And if you talk about some technicality, and if you see this on these sections, if you see this is less technical section. So if you go on a left hand side of this whatever the classification is there, then it is the less technical kind of things. And if you go on the right hand side of this classification, so it is a more technical. Okay, so we are going to see this isometric projection and this multi-view, that is orthographic. Okay, then what are the projection methods? So there are types of projection methods we have. So first we see this. So first one is a perspective projection method, and second one is the parallel projection. So what is mean by perspective and what is mean by parallel projection method, that we are going to see this. Okay, so our main concern is with respect to parallel projection method, that we are going to see this in details. So parallel projection methods is again classified between the oblique and orthographic. Okay, so this oblique view, again we are not focusing on this oblique view. Our main interest is in orthographic. So what is orthographic projection? And this includes axonometric view and multi-view. So axonometric view is nothing but it is the three-dimensional, we can say it is a 3D view, and this multi-view, it represents the two-dimensional view. Okay, so this is how we have to actually go for this classification. And our basic focus is axonometric views and multi-views. We are going to see this in detail. Okay, so this axonometric is nothing but 3D view, that is we can say isometric views, and multi-view is nothing but whatever the orthographic view we have. Okay, which is in two-dimensional, that we are going to see this in detail. So this is how we have to proceed. Okay, so parallel projection, orthographic projection, and axonometric and multi-view. So line of sight, what is exactly line of sight? So this is just a concept to imagine, and it will help you to draw the engineering drawings. Okay, so line of sight is nothing but it is an imaginary ray of light between an observer eye and object. Okay, so now you have to go familiar with these two concepts, that is observer and the object. So observer is nothing but yourself, and the object is nothing but the things which you are going to see. So this is the object, and observer is yourself, and the line of sight is nothing but that you are seeing any object. So whatever the imaginary ray of light which is come from your eyes, so that is called as a line of sight. Okay, so there are three basic things that we have to understand. First one, observer, that is yourself, then object, and third one is a line of sight. Okay, then if you see this line of sight, so there are two types of line of sight out there. So first one is a parallel, and second one is converge. Okay, so parallel, what do you mean by parallel, and what do you mean by converge, that we will see this. So first we'll see parallel projection. So parallel projection is nothing but when we are going to see any object in front of us. So this is the line of sight is there, so this is line of sight is there, this is the object, and observer, you are seeing this object from this side. Okay, and whatever this line of sight is there, and this is the object. So when we are going to see this object is parallel to you. Okay, so whatever the line of sight or the rays which are rays of light, imaginary rays of light we are seeing, these are the parallel to the observer, then we can say this is the parallel projection. And perspective projection. So perspective projection is nothing but it is the converge type of line sight. If you see this here, here is the object, and you are going to see this this object is there, here is the observer, and whatever the line of sight is here, and if you see this, it is not a parallel. Okay, so it come from the one things, or we can say points, and we are going to see this object. So such kind of projection, we can say these are the perspective kind of projection. So basic difference between these are how we are going to see this object. So this object remains same, observer also remains same, but the line of sight what you are seeing, so this might get changes. So when it is a parallel, then we can say it is the parallel projection, and when it is converged, then we can say it is the perspective projection. So we are going to see this with respect to example, what is parallel projection and what is perspective projection. So plane of projection, it is nothing but it is the imaginary flat plane in the image which is created. Okay, so we'll see this plane of projection is also very important things that we have to need to understand in engineering drawing. Okay, so we'll see this. So first we go with the parallel projection, and if you see this, so this is the plane of projection. So this is plane of projection is nothing but whatever the rays come from this object, so it's a fall on a one plane. So that plane gives you the idea, or we can say the drawing of that object. So that is why it is very important, that is plane of projection. So if you see this, so this is the parallel line, okay, which is passed through this plane of projection. Then second, if you see this, all these lines of projections, if you see this, it's on an edge, then like this, okay, like this, and if you see this, whatever all the points are here, and if you draw between the lines in between these points, then we got the shape of this, like this. So this is the image which is produced by connecting the points where the line of sight pierce the projection plane. That means whatever the rays which are going to pierce to the plane of projection, and if you draw the line in between these points, then we can say this is the parallel projection, like this. Okay, so this is nothing but this is the parallel projection plane, or plane of projection is parallel. And if you talk about the perspective projection, if you see this, now the same, whatever, this is the plane of projection is there, and whatever the rays which are coming from this, all the edges of this 3D drawing, if you see this, like this, in this way, now we can see this, all the waves which are going, they are coming to the only one point, or they are meeting just one point. Okay, so in this way, if you see this, so this is the perspective projection. And if you draw the line by intersecting this point, all this point, and if you see this, both the views, so when we are going to see any object in parallel direction, then you are going to see the actual size of this object. If you see this, we are going to see the actual size of this object. In perspective projection, when we are going to see this an object, then you are going to see this reduced size of object. Okay, so these are the basic difference between two projection, that is the parallel projection and perspective projection. Okay, then uh, we are going to see what is orthographic projection. So orthographic projection is nothing but it is the type of parallel projection. Okay, so what is orthographic projection? So it is the parallel projection technique in which the parallel line of the sight are perpendicular to the projection plane. That means the whatever uh, the planes are there, and whatever the line of sight, these are perpendicular to the projection planes. So that is why it is called as a orthographic projections. So ortho is nothing but anything which is 90 degree. That means anything which is perpendicular. So when we are going to see any object in front of us, uh, by using line of sight perpendicular to that object, then whatever the projections forms, it is called as a orthographic projection. That means it is exactly 90 degree when we are seeing any object. Okay, so we'll see. So if you talk about this example again, now we are going to see this object, right, like this. So there are different types of view, or we can say different ways we are going to see this object. That means if you going to see on a top of the side of this object, like this, if you are going to see this in a front side of this object, okay, then if you are going to see this in side of, this is the right side of the object. So there are different sides we are going to see this object, and according to which side we are going to see this object, we have to draw the different views. That's it. But the thing is that when we are going to see this object, then this perpendicular is very important. That means we are going to see this object with respect to the line of side which are the perpendicular. And if you see this, this is from the top side. That means we are going to see this object from this top side. Okay, so if you see this, so this is nothing but these are the orthographic projection. Okay, and this is the projection plane, right? And this is how. Okay, so if you see this, this is the first line. Okay, that means this edge, right? Then This is the second line. Okay, this is perpendicular to this projection. Then this is the third line, right? Then this is the fourth line feature. Again 3 and 4 they are actually coincide. Then this is the fifth one. Okay, then 1 and 5th again they are coincide with each other. And this is how this object is formed. But we are seeing this object, this is the front side object. When we are going to see this from this top side, so you are going to see this shape. Okay, if I mark it A here as, then this is the A. If I mark B here, then this is the B. Okay, and whatever the, if you see this is the C, so this is the C, right? So this is how we are going to actually differentiate between the various views that we are going to see. Okay, so this is nothing but it is the orthographic view we have. So orthographic view, so orthographic projection techniques can produce either, that is a multi-view drawing, that each view shows an object in two dimensions. Okay, so that means if you see this orthographic drawing, so we are trying to create in 2D format. Okay, that means what is D? So if you see this, when we are going to see this 2D, that means there are two dimension we are going to consider. So if you see this, there are three types of basic dimension. So first one is length, then there is width, okay, and then there is a height. So these are the basic three dimension, we can say three dimension. And when we talk about any two dimension, that means either we are going to consider length and or width or height or length. Okay, so these are the basic three dimension: length, width and height. And in orthographic view, we are going to produce 2D by using different projection methods, or we can say by using these parallel projection methods we are going to make a different views. Okay, so these multi views, it shows the object in two dimensions. Then axonometric views, actually it shows all the three dimension of an object in one view. So this is the example of isometric view, where the isometric example where we are going to see all the three dimensions, that is length, width and height. All three dimensions we are going to see in one view. Then it is a 3D view and it is called as a axonometric drawing. An example is isometric drawing. Okay, so that all shows three dimension in one object. And in multi-view drawing we are going to see this two dimension, and in axonometric drawing we are going to see three dimension. Okay, so both the drawing types are used for the technical drawing, for the communication. Okay, so by using this 2D, we are going to see the actual shape and size of any object. And in three dimensions we have got this idea of this size of that object, how it look like in 3D format. Okay, so both the way we are going to produce the drawing. Then what is axonometric or isometric drawing? So what are the advantage? So isometric drawing is nothing but it is the three-dimensional drawing where we are going to see the length, width and height. Okay, and what are the advantage of this? So it is easy to understand. When we are going for any isometric drawing or axonometric drawing, then we are going to see length, width and height of this drawing. And what is the disadvantage? So if you see this, the shape and angle may be distorted. That means if you see this drawing, so again this drawing needs some define some angle. If you draw some baseline here. Okay, and if you see this line, so there is some angle, right? If you see this baseline and this line, there is also some angle. So when your angle get distorted, then you are unable to draw this axonometric view. So it is very important to take care of this angle and whatever the shape that we are going to produce. So shape is nothing but this shape. So if you see this is circle, and when we are going to draw in a axonometric view, it becomes the ellipse. So that is why the shape and angle distortion is the basic disadvantage of this isometric drawing. So if you see this again, the right angle become the obtuse angle. Okay, if you see this, when we are going to draw this isometric drawing, then we need to concentrate on this shape and some angle which should not be get distorted. Okay, so this is the basic isometric view, or we can say this is the axonometric kind of drawing. Okay, is a multi-view drawing. So we are familiar with this multi-view drawing, and main advantage is that we are going to draw accurate shape and size by using this multi-view drawing. Okay, and what is this advantage of this orthographic or multi-view drawing is a practice in writing and reading is required. That means when we are going to draw the 2D drawings, we require it practice, because we are going to imagine and we are going to see this object. So here is your imaginary things comes into the picture, and it requires to imagine the shape, and that we have to convert into 2D. So it requires some practice and reading of this drawing. Okay, so there are two views. If you see this multi views, and if you see these views, that means we are actually looking this drawing in front of this. And if you see this, I mark here, this is the A, that we are going to see this A. Okay, so this is the B, that we are going to see this here as a B. You won't see this shape because it comes in a top view. Okay, so we are going to deal with this is the front side. So this is the front side, we are going to see this, and we are going to see these two parts, that is A and B. And this is nothing but your right hand view. That means you are going to see it from the right hand side. And if you see this is the C and this is the C. And what is this lines? So actually it represents the hole. So whatever the hole is there, and if you see from the right hand side, then it looks like as a hidden, right? That means it is, we are not going to see this hole exactly from the here. We can represent by using this hidden line. So we'll see what are the all the types of line that we are going to use in a drawing. Okay, so this is how we are going to represent this orthographic and isometric drawing. If you see this, okay, so we'll talk about the what is the difference between this multi-view and axonometric. That means if you talk about 2D drawing and 3D drawing. Okay, so here are some dimensions we need to give, okay, while drawing this 2D view. Okay, what is the comparison between these two types of projection? So this orthographic view, if you see this, it is used for the drafting map, flooring plans, all this whatever we are going to represent 2D on this paper, with respect to this various, by using various engineering drawing tools. Then we are going to produce the technical drawing, some drafting, some conceptual cases sometimes. That means we are going to use this orthographic view. Okay, so what is isometric? It is used for the conceptualization, and sometimes it is used in a technical drawings to see the object in clear vision. Means from using, for using these three-dimensional views, isometric views, we are going to imagine the object in 3D. Okay, So orthographic view, it is a set of three plane of projection. Okay, that means we are going to uh, imagine, we are going to draw these three types of projection. We can say front view, top view, side view. Okay, so these are the views which is respect to orthographic view. So orthographic is nothing but, again, it is the two-dimensional, and isometric is nothing but it is the 3D sketch. Okay, so whenever you come across any drawing, any design kind of things, then these two views plays very important role, that is orthographic and isometric. Okay, so you need to understand, we need to differentiate between these two views of projection, that is orthographic views and isometric views. Okay, so this is about the comparison, or between this orthographic and isometric. So that's all for this topic. So thank you very much. If you have any doubt, you can ask. Okay, you can directly connect with me, so we can try to solve your doubts. Okay, thank you for the listening. Thank you very much.